It's okay to go? Okay. So thank you for coming to our event tonight. So it's how to build personalization into large language model recommendations by Dr. Boris Galitsky. He's working at a stealth mode startup, Cybernator. And this is the San Francisco Bay Area ACM. If you're not familiar what ACM stands for, it's the Association of Computing Machinery. It's a professional society for computer science. We're a local Bay Area chapter. We've been going since '57. Not me, but just a series of people. We want to promote the knowledge of modern computing. We want to create community support of networking and hiring. Also, it's a $20 annual membership. We have upcoming talks on the meetup site for SF Bay ACM. And we have over 200 or so of our more recent past talks on YouTube. We try to have 2 monthly meetings, but we've been a little bit behind on some of that. No, I didn't know how to turn on. So we are aiming to have a general computing meeting, typically on the 3rd Wednesday of the month, and a data science SIG, that would be this, on the 2nd, on the 4th Monday of the month. So we have some upcoming ACM events. We have building enterprise LLM applications with retrieval augmented generation. So that's a PDS, or not a free event, but an 8-hour class, hands-on, with some cloud time involved. So there's early registration. Early bird registration is by October 28th. So that's coming up, where it's $65. After that, it's $85. You can register on Eventbrite. If you want to take a picture, here, this barcode will take you to the Eventbrite, or I'm sure you can just search for Eventbrite and SF Bay ACM. We try and have some consistent branding. Then on Wednesday, November 15th, we have non-fungible tokens, transformative potential, and risk management. For the people on Zoom, you could ask questions for the speaker, and the moderator will bring up the questions. You can also ask questions on technical issues. Also, we can do announcements for other events, for jobs. Yes, do you want to make an announcement?
Yes. I want to thank Hacker Dojo for allowing us to use the space here. They have hosted some of our other events, and they're also going to host, I believe they're going to host the November 11th
Yes.
professional development seminar on Saturday, November 11th. And, you know, it is a nonprofit, but a membership supported organization. So if you like what you see, please consider looking into getting membership to the Hacker Dojo, which comes with 24-hour access and the ability to put on events yourself. Thank you.
Mm-hmm. Thank you. Are there other people that want to make events about other related meetups, conferences, your company's hiring? I'll go from one side of the room to another. Just raise your hand if you want to make an announcement. Anybody care to make an announcement? Any other conferences going on? So later on in a couple of weeks, I'm going to the ODSC West. It's an open data science conference. So that'll be in San Francisco for 4 days at the end of October and beginning of November. So I haven't gone to that before, but it looked interesting and it was local, so I was going to give that a try.
So as a newbie,
Yes.
you understand the role of professional organization like ACM. Is it to help support like research work, job search?
So there's a central ACM. The headquarters are in New York. And so that works with most of the computer science departments and universities around the world. So a lot of the computer science journals and publications or computer science conferences would be through ACM. So the ACM is the .org. It's not a profit-making business. It's a professional society. So just like there's a professional society for electrical engineers, would be IEEE, the corresponding for computer science. And so most of the ACM.org's job listing is around getting a position at a university in a computer science department. So probably less oriented towards Silicon Valley. But just among us, you know, we can, I'm giving a forum where people can say, hey, my company's hiring a couple of software engineers that are doing X, Y, Z. My company name is X, stop by and talk to me later. So that's the kind of thing that I'm having us offer. just to do benefits. And then as part of our fundraising, some of the things we're supporting is in past years, we've done science fair judging. And so there might be 1,000 projects in March with a synopsis science fair. We want to support STEM education, science, technology, education, engineering and math. And so for that, we would give for 6th grade to 12th grade, first, second, third prizes to students and also to their instructors, their teachers. So that's something we've done in the past. And a lot of times we need just for that day volunteers, 20, 30 volunteers, because it takes a lot of effort to go through 1,000 projects in a day. The biology projects are categorized, but any group could be doing a computer science component. So we look at all the computer science component, could be something in biology, but they have an interesting computing component. So we do that for the judging. So that's one of the things that we do. And also if we can do other fundraising, then maybe we could set up some professional videotaping for the talks. So also we're interested in a call for volunteers. So if people are interested in helping out, so we've got about 6 to 12, depending on how active people are, volunteers with the local ACM chapter. So like I'll be more oriented towards finding data science speakers, somebody else will be more oriented towards food, somebody will be more oriented towards finances, somebody marketing. So there's different roles you can take. If there's some technology you want to play with that might relate to a meetup, maybe we could figure out something that overlaps with your interests. So now I'll introduce Boris. So his talk, he's going to talk about applying to any LLM model. It could be ChatGPT or Claude or Llama 2. And currently LLMs are not very good at personalization or providing recommendations. So a domain question from a physician or domain question from an attorney to ChatGPT may get an answer of, well, you should seek a professional's advice. It's assuming you're not that profession. And that's how it was trained. Okay, so that's a problem to solve. Another problem to solve is a question from a software professional, many times would likely relate in code. But if it's from a non-technical person, a software question maybe is more about getting answers that describe concepts or definitions of terms, or kind of an overview of what an algorithm is, but not necessarily code. So Boris wants to make LLMs provide answers to the specific user, given your background. And this would be in the context of a specific LLM application. So to do this with permission as relevant, kind of on a need-to-know basis, they could analyze a LinkedIn profile, the web pages you visit, investments, if you're talking about finance stuff. If it knows what investments you've already done, no need to recommend the same thing. If it's medical related, then if it knows some about your medical profile, then it could give more personalized answers to that. So he'll go into details about that. And again, on a need-to-know basis, what you want to share based on the kind of questions you want to ask. So he's going to produce a meta prompt that's going to be produced as part of the personalization profile. So he's going to do some analysis, and the output is like a meta prompt. So if you're familiar with prompt engineering in LLMs. So Boris's background, he's worked in linguistic and machine learning for Silicon Valley startups and companies like eBay and Oracle for over 25 years. He's worked at least through 5 acquisitions, architect of Intelligent Bots project at Oracle, developed discourse analysis and published a book on developing enterprise chatbots. He's published the 2-volume AI for CRM based on experience developing the Oracle digital assistant. So help me, please welcome Boris. Oh, okay. Be sure you have the slides.
Okay, good evening. So thank you for introduction. So I think this cool project was, yes.
The slides are not showing up in the screen.
Oh, I need to do, okay. I need to do screen share. Yeah. Yeah, I'll try to do screen share. Okay.
Can you do a mic check also?
Oh, mic is not working, so we tried. Sure.
Okay, and then also under the, we want to hide some of this Zoom stuff at the top.
Mm.
So there's under more, there's a hide, something that's hide this top bar.
Hide video panel, hide floating meeting control.
Yeah, that's right. Okay, and then,
There's a. Sorry. I just did. Can you just have it? I'll make sure, we'll try to work it out and then pass it on.
Okay, so I'll continue. So just I experienced this problem as a user myself. So I want ChatGPT to treat me as a software engineer. But if I feel it's not fair, like I asked medical question about my personal problems, and it was kind of very specific and hard to understand. But for software, so naive and basic, and I thought, like, why? Like I'm asking about Docker. I'm software engineer. I don't need definition of a Docker. I don't need the concept of a Docker. I need example. I need right example. So not always I need just a flat text saying, see professional, do this. Usually it's this, usually that. I don't want that. So I tried. Yes,
Close the mic.
okay. Let's look at first example. Can you tell me as a medical doctor how does colchicine affect people with single kidney? And then it's very broad, and the system is saying, I'm not a medical doctor, which is fine. But finally, it's saying, see a doctor. The answer is very broad and uninformative. If a user states that she's a patient, the answer will be the same. So let's look. And that is exactly what I don't want. So how we tackle this? Now we have this is the system I'm presenting. You're saying, I'm coming from this website. Like it's a hospital website. So I'm coming from hospital. I'm a healthcare professional. So the system extracted from the website, the system extracted this sentence, organization that focuses on pediatric cancer and other life-threatening diseases, and then extracted specialties diseases. So this is what we want. We want like tune this answer for people interested in diseases. Don't give a general answer. And then this answer is much better. So if you remember for the same question, how does colchicine affect people with single kidney? Now it's like answer can kind of starting making sense. Yeah, again, if you can go back, very broad, essential to consult with a healthcare professional. This is ChatGPT. And now it's particular and something we can understand. We don't have to be a physician, but for a physician, it's much more informative and exact. So this is the purpose. Again, we do a personalization profile. In this case, it's coming from website, but in general, we do like broad general case. Whatever information about user we can extract, we're going to use. Extract sentence, extract one entity, and now we say like go to the web, find information, and then adjust it to this entity, specific entity, diseases. And this, by the way, is done on top of base length chain system. So it's behind everything behind is a length chain. So what is happening? Given a web linked organization, the user is coming from, personalized, identifies sector and specialty. Now the prompt to answer the question includes the specialty, and the answer is not general, not generative, but result from the web summarized by LLM. This is not a generative answer. And this is actually good. We need more accuracy. So for different purpose, we don't always need generative answer. So the point is for different purpose. Like if you want to summarize, if you want to like introduce me to a subject, yeah, generative answer, okay. But if you want this exact relationship between disease and drug and condition, then probably you don't need to rewrite it. You don't care if it's original or not. You don't care if somebody who's already used this text. So we don't interested in text originality. We are interested in accuracy. And if industry is not medical field, then default LLM answer is fine. So what we want to do? So what has been done for last few years? A lot of deep learning projects, just in general, recommender. You can build recommender as a classifier. You have a bigger training set. You have sales data. You have like purchase data. You say what actually people bought. This is positive set. Everything else is negative set. You need to balance it, and then you do predictor. And this is pretty popular area well before large language models. We are also going to go this way, and we will compare this way with other approaches. And by the way, stop me if something unclear and you have questions. I think let's try to be more interactive. So first, we're going to explore prompting strategies. We're going to have input text with a question, but prompting will augment it. Like, here is a question and adjust it for different audience. That's a simple case, and we're going to see it at more complicated cases. Leveraging large language models, fine-tune and extended language data set. What is more important, common sense reasoning potential. If you just learn from data, it can be LLM or before, you're not really using common sense, but LLM already has common sense, and it's very powerful. Just that we need to properly extract it. Again, it's not explicit. It's not that, okay, here this rule is useful. And we will look at example and see sometimes ontology rules help, sometimes they complement, sometimes they not help. We're going to look at different. Also, personalization in a broader way. Expertise of the user, which we showed. Interest. So we want to adjust answer to interest. And also very different dimension. Communication style. It's a different technology. It's not related to recommendation. It is about how to match. Like if I am asking question and I'm asking in a certain style, how to match my style in your answer. And this is not really, it's a personalization in a broader sense. But I think it's makes sense to compare this whole suite. So we're going to talk about prompting. Then prompting is like hot area because everything is about prompting these days. Then background for personalization, just some background. How is personalization? How was it done before? Recommendation, how was it done before LLM? Meta prompting. This is like invention of this work. Abduction for personalization, also invention of this work. And personalizing communication style. It's also kind of original research from a little different area, but it's also again them like two-dimension content and style. So other topics talk about if you're recommending a product, just item. This is a content, but the style you're answering questions or recommending, it's a different dimension. You can recommend any product with any style, but your style, recommendation style, should match request. And we will look at example. And then we look, if we have time, overall architecture, like what lessons learned from this project. If you want to build a general machine learning framework, what kind of framework going to be? How we combine deep learning and something outside of deep learning. So let's look at prompting. I will read because the screen is small. So you start, the description of an item is as follows, like description, paraphrasing. That's a basic introduction. Then description of an item is as follows. What else should I say if I want to recommend to others? So this way, ChatGPT or other LLM produces tries to produce richer content. Then we have engagement. Summarize the commonalities among the following descriptions. And these commonalities will look into the commonalities deeper when we want to automatically build a recommendation like personalization profile, and also how we request large language model to build profile for us. What kind of prompting should it be? And then we have engagement and recommendation. Description of an item as follows. What else should I say if I want to recommend to others? This content is considered to hold some similar attractive characteristics as the following description. So it's a longer, more complicated. So we have again baseline recommendation. System want to use tags, automatically invent tags. And remember, in all the time, this is all manual procedure, separate natural language. Now it's all done by LLM. It used to be like old-fashioned recommendation system 5-10 years ago. These all done by different components. So very different architecture now. And I would say without LLM, you cannot really compete. So it has to be on top of LLM, just that take advantage of its strong features and do something about disadvantages. You can also add emotional flavor to your prompt. Engagement guiding. Leverage user behavior to design prompts intention to guide. Better capture characteristic inside the content description aligned with user preference. And then as a result, we get more meaningful description. Now aggregated. As you leverage user behavior, designing prompts to guide LLM better capture characteristics. Target item combined with the content. Important similar items. That's another thing. That is closer. So usually individual item is not a strong signal, but if you have a bucket of similar items and then ask LLM to generalize what is common, what are common good things, what are common disadvantages among similar items, that is usually stronger because again, individual product may have specific features, but a group of similar products, and if all of them popular, it's much more powerful source for the prompt. We want model to provide accurate recommendation. It's only user behavior, high-level summarization, user preferences, generate summary of user preference. So summarization is one of the features of LLM, and this is a good combination. So large language models can summarize, but then user preferences. The problem in a lot of time, user preferences are spread. So if you give multiple documents and LLM can summarize them, it's much more stronger signal because, for example, a long time ago, I was working in Facebook likes. Some likes, if like in my Facebook profile, I like certain rock music 10 times, it's much more stronger signal than for whatever reason my friend asked me to like something. So it can be random, but using LLM, think of LLM as aggregating my Facebook, maybe a Facebook profile of people similar to me, and confirming and also analyzing the comments using common sense similarity of my likes. And then out of me and group of my friends, highlighting 10 really reliable, informative likes. Think of it, this is what LLM summarization can do. And back then, like I worked on this 10 years ago, I have to do it manually. Basically, I have to program. Like there's certain different likes, I apply different rules. Sometimes it's working, for different people it's working. So for some people it works, for some people it doesn't work. And now this all can be delegated to LLM summarization. Questions?
You're personalizing for the user, but over time, there may be more and more fragmented apps in an enterprise for different specialties, like an app for if I want to ask HR about my benefits. And so is there going to be personalization also about the app domain? Because the app may say, oh, no, I don't answer questions outside of my domain.
Sir?
Yes.
Can you repeat the question for the?
Okay, yes, the question is, if so now it's a general broad personalization. Now it's a corporate environment, particular department, and it can be personalization for a member of this department or personalization for particular like specialty within this department. And again, a large language model has access to a lot of documents, like what people, for example, what communication, what different roles in HR department communicate. So then using this summarization, large language model will know what is random and what is specific. So that's most important. What is random for like bookkeeping for HR? What is specifically associated with this specialty? Using common sense reasoning, I acquired and summarized from tons of documents. So that is why LLM summarization helps in general case, but also helps in very specific like corporate case.
Can I, this
Yes.
is kind of clarifying, we're trying to follow up.
Yes.
So, I understand that you're using an LLM before the user asks any questions to analyze the user's
Exactly.
profile.
Yes.
And The LLM, now I have some questions there, like, the LLM then is it going to make a decision where to look? So if it looked on your Facebook page, there'd be all sorts of decisions as to
not
which friends to pursue.
Not that, not, I need to repeat question. Okay, the question is.
Yeah.
How will LLM guess which sources to use? And the answer is that is not, that is still up to my program.
Okay,
It's up to my program design. So LLM just takes text and then summarizes it. And how I form this text, that's still for me as a program assistant designer.
okay,
Because LLM doesn't, unless I specifically program, like go to Facebook, go to LinkedIn. For example, for some questions, it's going to Facebook, for some like music recommendation. For professional, it's going to LinkedIn. But I need to specifically program it. It's not that LLM can take different text. So LLM takes many texts, but LLM knows, okay, HR people, this is what they talk about usually. So let's find an overlap between all these documents and what I know about how accountants and how HR people express and building overlap. So think of like a large language model doing this overlap for me. But how to get original documents, it's still up to me how to collect them, up to designer. Yes?
So for using LLM for personalization and recommendation,
Yes.
what's the advantage of using LLM for this compared to traditional ways of just doing recommendation systems?
Okay, what I mean traditional way? I mentioned like I did a music recommendation. I need to look at likes at Facebook. I need to understand that some likes related to music, some likes are generally related to music genre, some likes related to very specific rock group. So I have to handle myself. How can I correlate like related to genre with like related to particular group? I need to find a genre for this group and then I aggregate and then I calculate some genre is represented 5 times, some genre 15 times. So first I should recommend 15 times. But LLM already knows how a row group related to genre. So basically, so then it does these steps for me. Okay. Yes.
Like most of the existing recommendation systems,
Mhm.
they might have some sort of like a feedback loop, like a reinforcement learning or something. So they might be sort of like built to maximize, let's take streaming platforms, things like how frequently which music will make the user hear more. So they will have some objective, and then the
Yes.
learning part will make sure that it can recommend those things. So compared to that, where will using this type of LLM based recommendation benefit is or helpful?
Okay, so the question is how reinforcement learning help here. So evaluation, if you get to evaluation, I'm not.
How does your system?
Yeah, compared to those recommendations based on reinforcement learning. Because now we are plugging in LLM as a new solution to the recommendation, right? So what is the added benefit here?
Okay, added that reinforcement learning it only knows the popularity, but it doesn't know how different items correlated with each other. There's no analysis like item level analysis. And language model, because it has common sense reasoning, you can ask, for example, how is this group related to this genre? And it will tell you. So with language model, think of it is the same skeleton for reinforcement learning, but just much more connection, because much more different relations with attribute, which is already acquired before, I mean, at pre-training time.
So
Yes.
we're talking about relationship between different things. I feel like, recognition system, built based on the collaborative filtering, also have this correlation between different, genres, group of people or something.
Okay.
So how to compare these?
Okay, we'll get to collaborative filtering in different, but at this point, collaborating filtering, similar people and similar items, but the similarity space is much richer for LLM because it knows the attributes. You can ask, like a recommendation system, old-fashioned recommendation system, it doesn't have information how one music genre related to another, because whatever is like you can have a fixed taxonomy. And large language model learned a lot of different interconnection between meaning of different music and music genre. So sometimes it's hard to find for real recommendations. Sometimes a collaborative filtering system just doesn't have enough links. And it would say, I don't know, because you're asking something not very distant. And language model should be able to identify connection between almost anything and anything, anything and something. Just because there should be some billion of text, there should be in some text. So the source of links for LLM recommendation compared to source of links with classical recommendation system is much richer.
Okay.
Yes.
So how does this process compare to RAG?
Oh, so what I showed is it is RAG. It is
Okay, so this is
combination.
like
It is
RAG.
basically personalization is done on top of LangChain RAG.
So right would be during the question answer. This is before the question answer. You set up the initial prompt to be specific to your person.
Okay, gotcha.
So it's a right to set up a meta prompt
Right, yeah,
about you.
gotcha. Yeah.
So I have a question.
Yes.
So some of your answers about what to pull in, you said you decide as a programmer. How do I opt in on some things and not others? Let's say I'm using a word personalization for one, word becoming professional. But then let's say in my personal life, I use something else for fun. You know, find fun events to go to, and maybe I do something else for you know, a different kind of like medical. I don't want my medical opt-in to lead into the other apps.
Okay, so the different personalization. First, you should be able to switch profiles. In my demo, I showed you give a link, but it can be like you open one window in Google Chrome and then you open a RAG window. But Google Chrome knows, okay, this is a window like Airbnb. We're going to look at example, or this is window going to hospital. So then you're coming from hospital. So in general, you may be interested in a million things in life, but right now you're coming from hospital. So I'm going to personalize for health. Let's look at this example, a music recommendation, two-step process. First, natural language user profile generation. Your task is to use two keywords to summarize user preference based on history interaction. Output is itemized based on importance. Output template is keyword is movie, keyword movie. And this is a sample output. And then second, actual recommendation, second step. Recommend 3 other movies based on user watching history from the candidate list. They have, and this is our output template. This is the prompt. And then the system recommends user history interactions, candidates, and particular recommendation. So 2 steps. One, prepare profile, and then using this profile, recommend. And this is not textual, this is item recommendation. So this is substitute for collaborative filtering, which you asked. Okay, questions here?
Have you done any benchmarking with collaborative filtering?
We'll get there.
And it occurs to me also another advantage here is that it can potentially explain why these recommendations.
We'll get with abduction, we'll get specifically to explanation.
Yeah.
Oh, the question, the comment was that using LLMs, you can help with explanation. And that is like our item number 3, if you get there. So abduction is like forced explanation. It's like maybe it's not exist, but it's making system build explanation, like enforcing it. We will get there. So architecture so far, we have the user interaction, we build profile. We have 2 types of input is purchase or selection history, a list of recommendation. We have object level and meta level prompt, which we will discuss, and final recommendation. So this is a simple chart. And then more specifically, like what you do. For example, a more specific case, you want to do financial recommendation. So the system can look at your tax return, but tax return, you don't want to share personal information. So first, your tax return is ID identified. Then it's from different years, because maybe different years you had different jobs, but general from your tax return, you can figure out what kind of investment you should do. And then aggregate the identified document into personalization profile, build it, have a map, and then how can I?
You can in that box on the left, yeah, that will. Yeah.
And then this is now offline, like indexing time, search time, recommendation query, classify it, find entrances into personalization profile based on the sentences form prompts, include relevant personalization profile portions, and then run like regular search. And investment is particularly bad. So like if you ask for investment, like what's OCD, particular state, what kind of investment strategy, ChatGPT is really cautious not to give you anything exact. But if you have your if you have your tax return, I mean, if I look at your tax return, I will. Then exact information, your total income, how many debt you have, do you have like mortgage interest or whatever? Then it's ChatGPT has this knowledge, just it's concealed. So, but once you have information from your tax return, it's aggregated in a proper form, and then you pass it on. Then ChatGPT, even ChatGPT and other can give you very specific, because it has this knowledge, just prepared to only default ChatGPT prepared to give you very broad, so you don't risk like it give you wrong advice and then you're unhappy. But with personalization, it will give you specific advice to your financial situation. Yes.
So there was a question from a remote user. Can you show an example of a personalized prompt? What it would look like? Would it be human readable or would it be really large?
Oh, let me go back to my example, but I have more example. Let me.
And also that box in the top center,
Yeah, I have.
you get rid of that box with the X.
So first was. Why can't I? Here. Okay. So there is this example of health, which is extract. I repeat, specifically diseases extracted, and then prompt formed from diseases. You don't see the prompt, but the prompt is easy. It will look like answer question, but how would you answer this question for people for specialists in diseases? Very simple. We're going to look at a different example, but in this case, it's very simple. Maybe, yeah, we can run forward. There are more examples. There are more. Okay, dietitian example. For example, I'm coming from WebMD, healthiest way of cooking, and then answer is related to cooking. Then, like this example, and Investopedia, investment, and then best way. So, in best way, inflation. Different people concerned with inflation, like gas prices or whatever. But for investors, it's one way. So it's specific answer.
Example of the prompt that you generate.
Okay, take answer and how would people specializing in investment would answer? Answer for people specializing in investment.
Okay, you're not displaying it.
I'm not displaying the point, but I'm almost. So in other example, I almost showed whatever was extracted from the site. Let's look at, for example, question. What is a typical paycheck? Like in general, this general question doesn't make sense. But then it was user came from GitHub, organization in software development industry, and then the answer is salary for software development industry. Otherwise, question is not like what is a typical paycheck? It's not. It's too broad.
So
Okay.
if I understand this correctly, you just give a handle to the LLM, the language model. Just say, okay, look up in the Wikipedia or wherever.
No. From so user say I'm coming. User is explicitly saying, or Chrome knows I'm coming from GitHub. So you have an open GitHub page, and then you're asking, what is a typical paycheck? And then system infers, okay, you're coming from GitHub, then you're interested in software engineers.
But the system still needs to retrieve all these contextual information from where you're pointing to, right? Like GitHub or like.
So then the question: answer is going to be generative from ChatGPT or is going to be from the web? That's a secondary question. But the prompt for the answer will be substitute whatever you extract from personalization into the query. Like it's like in old fashion, before language model, before deep learning, we called it query expansion. So we have a context, and then we substituted keyword into the query from the context. It was a very old-fashioned, easy way.
But I still
before.
Sorry, but I still don't understand where your prompt is generated. Where's your prompt generated? How can you retrieve it?
Okay, so you have a GitHub page.
Okay.
Then I ask ChatGPT, GitHub, people on GitHub, which industry in this? And the system is saying software development industry. And then I substitute software development industry in my prompt. Okay? Like provide an answer for the person or for the domain, which is software development industry. And think of it, we take this query and just add what is a typical paycheck in software development industry. And here's the answer.
So are you like a web plugin, so you know what web page you would just add?
I haven't implemented this, but it's Zoom. So for simplicity, I have, like for debugging, I have URL, but I'm sure it can be easily done. Just capture, go to Chrome and ask, what are the open pages? And what was the last open page? The last open page was Airbnb. Then I adjust my answer to travel.
Do you have an example of how to generate some prompt?
Okay, I have more specific. So this is a simple example. Again, this prompt is hard coded, like answer this question for, and then I have the string specialty, and specialty I extract from web page I'm using. We're going to go get to much more complicated, but this is relatively simple. Again, the prompt sounds give this answer. You know, we can just go in my code and see what would help. Just I have the exact string, and or we can do it like I can share after if you have questions.
To summarize the context you interpret, how did you add this part to the prompt?
Or you have in prompt. Okay, the question is what it's called soft prompting. This hard prompting is just fixed string. Soft prompting is fixed string plus some substring, which is determined on the runtime. So in runtime, I determine the specialty. I have a soft, what is called soft prompt. The hard part of it is adjust this answer for domain, and then domain is determined at runtime. Okay.
Sorry, doesn't LangChain sort of tries to solve this problem of hot prompting by helping us build chain of questions with context?
Yeah, this whole thing is done in LangChain. So first, this is like first part doing personalization profile, and second part actually answering questions. So these are steps in LangChain. These are chain. I mean, this is chain. These are steps, elements of the chain.
Most of your, so I'm able to follow, thank you.
Okay.
You do typical sequential chain, or are these more complex workflows where one context is coming from, the Facebook page, the other context is coming from what was the last visited page, and the third context is coming from.
What I'm showing much simpler. So you have first at personalization, like preparation time. You just identify the entity, like specialty as an entity, just one word or a phrase. And then you have, again, soft prompt, you substitute this phrase. And the last step, you just do search. There's also summarization. So I'm not going to detail this. This is also done inside of LangChain. You have search, and then you have multiple search results. And we can actually look at them. I mean, if you run it, and then ChatGPT summarizes or whatever, the summarization. So this is a classical path other than personalization to the site, to URL. Okay.
Can I ask another question?
Sure.
So you mentioned you can use LLMs to do this, investment recommendation, right?
Yes.
I used to be a quantitative analyst, working for investments, and we use very specialized data sets to, basically build a model and trying to piece out all these correlation, causality between, the price trend or all these different investment vehicles. It's really hard to believe all the, all these leverage models can integrate with all these specialized data and have this, relationship correlation between, when to buy, when to sell, how to, buy different, vehicles. So it's really hard to believe you can actually add a layer of prompts and, enable them to give a really good recommendation. So can you explain a little bit more on that?
Well, I actually work in a pretty much, I work in the opposite end of the spectrum. So he used to work in HFT, right? Like as a quant. So he used to work with very small time series. I work on the opposite end of the spectrum. I work on investments that play out over multiple years. For you, your task might not have much use because you operate as a quant in very small time series. So you're not paying attention to the natural language that is used in filings. But I can as an equity analyst over a long period of time when I'm actually analyzing a corpus of text, i.e. SEC filings, PRs, etc., in specific domains. So say like in healthcare equities, I would not, obviously to generate alpha, we would not be using a prompt and being like, hey, should we go long or short, whatever. But I could see it helping us parse through a giant corpus of financial data that is textual rather than like the general like columnar data that we might use.
So you are talking about value investor, like value
Yes.
investor versus like day trader.
Sure, maybe not necessarily value investing, but yeah, just general any long short technique, not like something in a small time series as a high frequency trading, but like if you need to look at a ton of data that you just like you need to analyze companies and look at comps, I can maybe see one. I'm sorry for answering for you, but I can see like
I'll go to
one application.
Yeah.
It's like one I can see.
Yeah, that makes a lot of sense to me, but also language model actually have this, trained in the history problem, right? For example, at 0.5, they actually have a cutoff.
Yeah.
Correct, and you don't really have all these financial statements actually integrated. with
Yes,
your
that's a
model.
problem that I'm working with right now. Yeah, so
Okay.
the SEC file was cut off at a certain modern SEC files in an LLM, right? Because GPT-4 cuts off at like.
But does the big chat help with that?
No, definitely not. I've tried. Bing, with GPT-4, Bing, it does a really superficial lookup of the SEC filings. It's not really efficient. It's not kind of what I want it to be.
But a solution we can propose here is we can have this sort of prompt chaining, and then we prompt some URL or whatever your resources can point to, and integrate with all the financial statements on a big layer of prompt, and then integrate that with the cutoff LLM somewhere in the history, and then probably can generate some more like convincing without.
Let me comment. So we are discussing how to improve the search, how to make like in finance, search needs to be much more accurate and it needs to involve much more entities and relationship. This question is orthogonal to personalization. So this is discussion is how ontologies and how like structured and improved knowledge representation help language models. They definitely help. Just with a different question. This is a question how we in general answer questions. And again, it's independent of personalization. Very interesting topic, separate discussion, just not related to personalization. Because personalization is knowing who you are, and then knowing who you are, the best question. We are talking how to give the best answer. Knowing who you are. How to avoid irrelevant.
Example at the beginning of a doctor don't tell you to see.
Yeah. But this is it's relevant. It's irrelevant in personalization dimension, but it's relevant. If I'm asking medical question, it doesn't say you, I'm not a financial advisor. It did tell you I'm a doctor. So it recognizes domain, just that the style, it doesn't adjust the question. It's still relatively relevant because it's a medical question, then it's a doctor. It would be relevant if it, again, different special. Yes. Yes.
In terms of personalization, how large is soft or the soft prompt should be, and what kind of information you want to put in there to make sure the prompt, the response is properly.
Okay, the question was what kind of prompt, how to design prompt, and the answer is very simple. Make an answer specific to this specialty, and that specialty is a soft part. That's it. Very brief, very simple. Just adjust the answer for this specialty.
In natural language? Or
In natural language, in natural language.
Okay, so like in this case would be, so the domain, like the user came from GitHub, right? In this, what would be the soft?
I'm going to post again. I'm going to post link to my code. Code is on GitHub. It's as simple as just simple string, a prompt. So there's nothing special. Just personalize just the answer for. So the language model understands that pretty well. Just adjust your answer for if you are just this answer for. And I experimented, varying doesn't change much. So if you have this kind of, it's pretty broad, you can say pretty broad, as long as you say like software engineer or medical or disease. That's it. And then large language model selects whatever is relevant.
Makes sense.
Okay, let's go back. Let's talk about so very briefly, general recommendation, collaborative filtering, user item interaction, user item algorithm extract potentially interesting items based on the idea that users who have shown similar preferences in the past are likely to have similar preferences in future. It's a general machine learning, use past, predict future, the simplest possible formulation. So collaborating filtering has cold start. So it's hard to start because you don't have any data. But with language model, it's already common sense reasoning is already there. So even if your existing collaborative system, if you don't want to substitute it, at least use proposed approach LLM for cold start. And then features grouped user side information, user profiles, item side information, brands and categories, and then interaction based, like reviews and comments. And this is all can also be incorporated into LLM. And that's some visualization. So deep learning, it's the same structure as before, but now we have higher order interaction, or think of it like interaction between more distant items. But in a lot of cases, it is useful. Like I killed myself at eBay trying to figure out, like, people go to sports and then people go to restaurants and find correlation between restaurants and sport, and not much correlation. But now I'm sure, that was like 10 years ago. Now I'm sure LLM knows some correlation between sports and what kind of food people eat after sport events. So this is example where back 10 years ago, you have to kill yourself trying to figure some correlations, and now it's already, you can extract them. You cannot extract explicitly. I cannot get a table of values, but if you put your problem in the context, LLM will apply, and it has some common sense knowledge about food and sports. So history is pretty much from minimum description length, simple rule-based decoding, and then different neural architecture. Let's run quickly. So difficulties. Understanding of user preference. It's a domain-specific knowledge. But again, this is a question, domain-specific knowledge, it's hard to like Claude. That's a limitation of LLM. So it has a lot of hidden common sense knowledge, but you cannot just easily combine hidden with domain-specific. Like, for example, you can have Prolog program and you can have database, and then you can easily integrate. That's obvious. But in LLM knowledge and whatever knowledge you clearly have explicit, it's an hour. So that's a disadvantage, right? That is why how to efficiently adapt. Also confidential. So profile is confidential. The data about products is public, data about individuals is confidential. So what can you do not giving this data to LLM? And that view, this is a Azure, like, so I showed how it can be implemented on top of LangChain. But Azure also gives you platform. It has chat history, it has customer info, product information. So the same thing can be built on Azure, just as an example. Yes.
Regarding confidential data.
Yes.
Is it possible to query, an LLM?
Yes.
About the user's confidential data without actually passing confidential data in the prompt? I'm not quite sure.
Okay, in my example, so what I do, I take tax return, I have de-identification software, I run it, and then I don't have names, I only have like numeric ranges, and generally I don't have company name, don't have person name, which is not really needed for personalization. I just need what kind of like positive balance income from rent, expense for office. That is what I need. I don't need office address. So, and once it's de-identified, then it's aggregated, and then it's ready for profile. And then We don't care about leaking. We don't care about sharing. Now meta prompting. This is a big thing of AI. Now we need to take a step back to abstraction. This meta thing, it's a big thing in artificial intelligence, self-improving system. And now this is actually becoming, with ChatGPT, that's one thing which is actually becoming popular. So there are experiments with large language model chatbot, which modifies its own instruction. So let's look at example. We have instruction, human, then assistant, then analysis of it, then critique, then updated instruction. And this is a very cool, simple program. I don't think we have time to get into the code. Just the idea, the introspection in like reasoning domain. It's called introspection. How I can look at my own behavior, how I look at my own reasoning from looking at me from outside and improving it. And this is a simple code in linked chain, which has a chatbot. It does conversation, and then it improves, it criticizes itself. This code, you can get this link from my presentation, which I'm going to share. And the prompt looks, this is a more complicated prompt. Assistant has just had the below interaction with the user. Assistant followed the instruction closely. Your job is to critique the assistant performance and then revise the instruction so that the assistant will quickly and directly respond in the future. But again, this is example of meta prompt, but this is not for personalization. I'm just giving examples. This is an existing example of a meta prompt. So what we need for personalization? So we need an abstract way, a way which doesn't depend independent on particular documents. I'm telling. Now formulate a meta prompt which would take documents for user and build a recommendation profile for them by finding commonalities between various documents. Why commonalities? Like, look at my computer. I have my tax return. I have my hospital discharge form. I have other documents. Each individual, like I had my blood test particular year, not very helpful. But if I have different documents and something common between them, that is the strongest signal which should be included in personalization profile. So if a feature appears in multiple documents, it is a reliable indication that this feature can cause correct personalization. This is coming, the root for this is it's an English, British philosopher, J.S. Mills formulated in 19th century, like canons of induction. This is very, very beginning of machine learning. What does it mean to learn and predict? So that comes from foundation. And then this meta prompt builds a series of object level prompts. So for example, object like go to Facebook, find likes, go to LinkedIn, find recommendations, find jobs, find whatever. So now we have a higher level, this is a higher level meta prompt, and then specific prompt. Now it depends on the documents, and ChatGPT can actually invent ways to extract, right? It can invent. So human now, it's like meta programming. Human programs meta prompt, and then object level, actual prompts, still soft prompts, which will be run, partially invented. You can invent manually as a designer, but some of them are invented by the system for you, which is like programmer's dream, right? They invited for you, invented for you. And now maybe questions for this, and then we go to abduction. Questions for meta prompt? Yes.
It's not a commonality.
Okay. Okay. So in this approach, if I look at your computer, I want to personalize information just with your computer. And if you only have one genome analysis, I think, okay, maybe it's your friend, maybe. So just one is not good enough, not reliable enough information. If you did genome analysis twice, maybe for genome analysis particular, that's not a good. But in general, for to be confident, I need double confirmation. This is philosophy. So yeah, some important documents maybe occur just once. Like tax return, you do every year, but maybe like criminal charge, you only have once per life. So criminal charge is not going to be used. Because it's supposed, according to this model, it's supposed to be not reliable enough. If only happened once, not reliable. But you have two documents and the same thing, that's coincidence. Coincidence has low probability. So if there's a coincidence, there's a high chance that it's informative and should be used.
Boris,
Yes,
regarding meta prompt,
yes.
how robust is it? Can it, I mean, is it good enough for, being put to production and actually, performing some tasks? And what are those use cases for meta prompt?
For meta prompting use cases, so I do manual, I know about tax forms, I know about like Facebook profiles, but in like, for example, you have different company, you have specific forms for this company, I don't know anything about it. So this meta prompt will look and will automatically tell you, like, take, for example, image captions. Image captions are informative. So this example, what ChatGPT can invent for you. Okay, now abduction. So abduction is another approach. System, what is abduction in learning? System seeks to find the best explanation of model that can account for observed data, even though information can be incomplete or ambiguous. So in deep learning, everybody's dreaming, everybody's complaining about, and there's reason, there's a problem with explanation because it gives you result. But this is the opposite approach. Whatever task and result you have, force it, find explanation, whatever. Just build it, whatever you can. And in this approach, we try to build explanation or recommendation. We try to force ChatGPT to build explanation. And then we will look, let's look at the model. It's one way to combine deep learning model and logical reasoning. So abduction is done by logical system. Abduction is useful when you have some axioms. And in my case, I was experimenting in axioms about knowledge. So I simply manually encoded, like you have different levels of knowledge. You are beginner, you're intermediate, you're advanced, and then in your main domain, then you have a relationship between domains and relationship like knowledge level. So if you advance in programming, then you're at least like intermediate in math or something like that. And this is easy, ontology easy to hard. And based on that, I used abduction. So we have LLM. Now we have logical abduction. So what we assume here, LLM, so learning system is noisy. It gives results, they are non-personalized, but noisy. Now we consider, we do this reasoning framework. Reasoning improves noise. So prediction, like machine learning, is always noisy because it learns from data and data is noisy. But now we have rules. And if, in my case, in my example, if machine learning gives rules, for example, recommends something beginner to advanced user or other way, then logical abduction fixes that. So again, think of it in a broader perspective. We have a learning system, and as any learning system, we have some errors, some confusion matrix. Then we have logical abduction, which corrects prediction. Then this corrected prediction feeds back. We have fine-tuning with correct precision. Then we look at results again with abduction and correct it again. So this is iterative process, machine learning reasoning, And this is like real reasoning, not in the real sense, not LLM reasoning, like real reasoning. And then, because it's actually like strict enforcer of this rule, for example, for knowledge level. And it turns out that it actually improves recommendation because by prompts, you can not always achieve something we can achieve by abduction. Yes.
On the right, you have labels. Is this how many labels are needed? Is this like 5 labels, 50,000 labels?
Okay, so in my case, labels is knowledge level. So we have domain and knowledge level. We have like 20 domains and 3 knowledge level, beginner. So this is a very small logical system, looks like manual. So this is real LLM, but this is very small logical system. Okay, because like in my example, I experimented again, 3 knowledge levels and 10 domains. And then some correlations. So if I said that I'm an expert in programming, then in computing, in engineering, I'm not a beginner. That's a logic. And it turns out that this logic improves.
Clear about the person.
Yes.
That's what the label is.
So now I'm have stronger ceiling than prompt. I'm actually verifying that if I'm an expert and I'm asking question in my area of expertise, then it's expert answer. I'm explicitly not by prompting, but I'm actually verifying that by abduction. Yes.
So in the process of abductive reasoning, are you basically making the LLM tell you which input features were influential in creating the output?
No, abduction, that's a real reason, not, I mean, I'm in this whole talk, I was very positive and supporting about common sense reasoning of LLM, but now I'm saying, no, the real reasoning happening outside. So I'm taking LLM answer and checking with prompt. I'm checking answer, think of it answer with prompt, and then I'm checking, but did it actually achieve what I wanted? Did it give expert level answer to expert level person?
Okay.
I'm actually testing
Right.
explicitly, not by prompt, but actually verifying that.
Like as a human, you using your.
Like, okay,
Yeah.
no, it's automated, but it's outside of LLM. It's biological rules.
Okay, yeah.
Rule-based system, biological
Yeah.
rules. Biological.
How would you transform like the LLM output to logical rules that you can analyze?
Oh, okay. So now I have a simple classifier. So question how I transform LLM rules to be compatible with logical system. Now this is done. I'm taking LLM answer. I have a simple classifier for expert level based on what LLM gives me. And then I just explicitly verify. Again, beginner should get beginner answer. If it's similar domain, then for beginner, it's either beginner or intermediate. Basically, I'm directly verifying this. Okay.
So in a sense, you sort of define some rules that helps to classify.
Your rules which help to classify expertise level.
All right, and then you, based on that, you just benchmark whether the output.
And then I enforce. I basically filter out. So before using prompt, whatever with prompt LLM gives me, I'm happy. Now I'm not happy anymore. Now I'm gonna do additional verification by the rules, by abduction. So I want to explain. Now I'm explicitly explaining. I'm giving this answer. This is expert answer because you are expert. Or I'm giving beginning answer because you are beginner. So this is a real explanation, not like a LLM explanation. Yes?
You retrain the model, or if you don't retrain the model, I don't think the model will follow it.
Actually, in this model, I do. So I have a fixed model, then I get abduction. So because this is also improving LLM itself. So I have my like existing model, but I can do fine tuning. Based on this data, I'm doing once I relabel by abduction, I relabel LLM results. I'm giving the label that back and read and fine tune. Then I do it again. I do it again till it converges or till there's no improvement. But with multiple fine tuning, because each time I verify results by abduction.
Good. But how do you verify your new rule, the new logic you added in?
I'm not changing. Logic is fixed.
Yeah, but how do you know if it will generalize well to other situations? You know,
Oh, that is a problem. That is my problem as designer of abduction system. Obviously, there are some disadvantages. I'm just enforcing this model, which I described about the expertise level. But you're not changing it. You're changing the LLM. You keep fine tuning. So whatever mistake LLM does, you give it back and fine tune.
Whether your logic, will applicable to other situations.
Okay, this is a problem. If so I have my model of expertise level. If it's applicable, that's my problem outside of LLM and outside of recommendation, outside of general implementation. So if my model doesn't cover 100%, that's my problem as a system designer. But the model is simple, and I don't see it's some approximation. But with this approximation, prompting is overwritten and is the positive way, because that can be evaluated. So it turns out it was experiment, because potentially with my simple model, I could drop the accuracy, but it turns out that it's improving because by
I think that there could be a problem because personally, when you train the model, personalize to yourself.
Okay.
You have limited data, right? And you have limited time to spend to really verify the after retrain the model. You know,
Okay.
you give very finite test. Then with finite test, you know, it's
So we have a discussion, we have a language model, and we have like experts with rules. And discussion is sometimes expert rules can break the model, can even make it perform worse. It is possible, but you have to check. It is possible, but you have to evaluate.
If you have a very limited test, right? You might not.
Then you need to, for this model, you have to test it. So if your test shows that this system improves overall thing, then you keep it. If you add logical abduction and turns out that overall accuracy is lower, then you don't use it.
Then really depend on how much test data
I mean, assume it's like any testing. Assume you have normal, like machine learning, in machine learning sense, you have a training set, like evaluation set, assuming you have like follow machine learning strategy.
You might not have a lot of data.
So I think we have an option here. Now I have some basic reasoning problem, some basic reasoning, right? And then if you have a, you can see this logical adoption as a guardrail, and you set a guardrail if it's all on an open border, and then you should bring the best, right? And then if you, like you said, if you don't have much personal data, and then that means this situation doesn't really happen that frequent,
Right.
right? So then maybe you do have that requirement to put it back on track anyways, right? Because it doesn't really, it's a once in a lifetime experience. Then, if you pass it and then that's it, it's a hit and miss, right? So you don't really need to do that anyways.
But then you might have to train it again.
No, you don't have to. Like I said, you don't have that requirements in the model because that only happens at one time in your lifetime, and then you will never encounter the problem anymore, right? Sorry to interrupt.
Oh, maybe I repeat it. So what we are discussing, we have language model and we have expert, and sometimes expert disagrees with language model. So what do? Pretty much in a broader sense, that's the discussion we're having. And I'm saying what we do evaluation, and if it turns out that when sometimes expert overrides LLM, and if overall it's better, then it should be used. Okay, so your question.
Okay, so what the expert will like fine tune, what you would use the output from the expert to fine tune the model, right?
This is what I described,
And
yes.
so this you fine tune model for everybody, or personalized fine tuning for every user.
You have like a different or matrix.
Okay, in this case, it's not per person, it's per, we do like expertise level. So we do different persons, and then we see for like 400 persons, what is happening if I override based on my, as an expert, as a designer, my simple rule related to expertise.
So you might have one more matrix for doctors, another for lawyers, another for software engineering.
Okay, the metrics here is, so I have evaluation. There are some product recommendation data sets where I tried this. And some products are for experts, some products are for beginners. And that is how you evaluate. And then these data sets have standard evaluation metrics with other research. So I compared with existing studies. So the evaluation framework is fixed. I just changing algorithm. The data and evaluation framework is fixed. I took it from somewhere else.
Yes, have you evaluated the data?
Yeah, let's get to evaluation. We'll skip.
Try and remember to repeat questions.
Yeah, so the question about evaluation. We're short on time, so we'll skip some stuff. So we split training, validation, testing, we split. Negative training data set created from something which was not recommended, and this data set assumed we have like correct optimal recommendation and everything else. And then we pair observation user item, 1,000 items. 1,000 items are not applied, and metrics precision. In DCG, this is the metric for search. This is in gray. We have different studies. We have 4 data set, movie lens, recite, Yelp, and sports, different recommendations. Again, this is not a central part for the study because this is a recommendation for the series of products, but some signals like level of expertise for products is helpful because if you recommend product which is relevant, which is similar, but for professional photographer, if you recommend beginner camera, if you have this explicit rule, and you prohibit this is improvement. And then we measure and have some improvement measured. So we have baseline. This is a learning based recommendation. And this is abduction and meta prompt. So features we discussed, this is a preliminary. So we had some estimates and look at cases where particular cases improvement or when this rule breaking something. And then we have, so it's a few percent improvement. So our own baseline, it's based on pure, you have data, you just learn it. You don't really think of a specific personalization, just consider personalization as a prediction. And based on that, it's meta prompting like 7% and abduction 12%. But again, this is a preliminary evaluation. And this is because this is not the central focus of this study is a general recommendation. You have question and then answer for you. But this evaluation is for items, for purchase for items. So this is not again, and I have not come, I don't know, still thinking what would be the best evaluation other than automated for what I'm describing. Well, this is like some overlap between what I'm presenting and what has been evaluated. So I used it, but this is the central, that's not the best evaluation framework. This is just a standard framework other research we're using. Okay. So examples. Should we more questions or will some new stuff?
Continue on the slides.
Okay. So let's totally different topic. Now semantic, syntactic and discourse structure. Now we have personalization communication style. So this is very different logic. This is not item personalization. This is like style. And everything about relevance, it's so you have a question and you have an answer. And everything about relevance is very simple. Your answer should be as close to question as possible. But let's jump to examples right away. So, like I'm asking somebody, like, what did you do yesterday? But then I ask, what did you really do yesterday? Do you see the difference in, so how can, and that's beyond ChatGPT. How do you, like, I assume you did something special, like something you don't want to tell. So, and you want to have different answers. If it's like a routine question, what did you do yesterday? Oh, just fine, I had my lunch. Like, what did you really do yesterday? Like something special. So there's a very insignificant difference in phrasing, but the answer logic is totally different. In language models, they cannot do that. So we have to do it outside. And to do that, you need to have discourse representation, which I'm going to start with example. Like, what does investigative committee of Russian Federation do? This one official answer. Mission statement, blah, 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 investigation committee, investigating authority, all this legalese. But then this, what does it really do? And it's actually involved in organized crime. Okay, so the same question, like what do you do and what do you really do? Linguistically, it is the same question. But because of subtle difference in your logic, you expect very different answer. And in general, this is personalization for style. And in a lot of conversation, again, if I'm asking, what did you do yesterday? And what did you really, how did you code this function? How did you really code this function? It's a sarcastic question. There are many different additional senses. And today, language models cannot do that, but for personalization communication style, it is important. So for that, we use linguistic analysis. So we have syntactic level and we have semantic level. And this will not, both of these levels will not help here because the question, what do you do and what you really do, syntactically almost the same, semantically also almost the same. So where is the difference? The difference is discourse level. And this is why discourse level is important to organize dialogues. And that is not, it's not explicitly existing inside LLM. This is another thing which LLMs are missing. So you have to do it outside. Discourse tree is a presentation. You split the whole phrase into parts, like elaboration. Like I went shopping and I bought bread. I went shopping one part, I bought bread another part. But then there are more complicated relations. I bought bread, although I was not hungry. Like in this, however, for the real answer, you need contrast because you expect one thing from law enforcement agency. You expect like doing law enforcement. So the answer should have. You would think that it does law enforcement, but actually it supports organized crime. So that is why you need contrast. It doesn't matter what organization name, what does it do. It's only high level logical structure which matters. And that is important for communication style. Yes.
You said that LLMs today cannot do this,
Yes.
but I think they can. If you just like, ask them to provide you with a vision statement, they will give you something like that,
Okay.
But then you can ask, okay, what actually is committee does?
So I couldn't get that. If you have examples, I would be curious to see, but in many cases it doesn't do that.
Okay.
The kind of next level you have to build on top. And that's also personalization, just in a different sense. It's communication style.
Does this tie into like personalizing to a person's ideology?
Yeah, I have the same question. Actually, people have different perspectives, right? And you said, what do you have lunch and what do you really have lunch? So, in different people's eyes, you have very different answers to a lot of questions, right?
Okay.
So how can you, emphasize and also make sure this is the answer that person.
Okay. So if you have the high level rules are similar to like expertise rules. If you have a sarcastic answer, you have to have contrast, you have to have contradiction in your discourse representation. Because like default answer is always like additional elaboration. Joint means just more information, be more specific. But this is very different. Contrast means you would expect one thing, but actually it's different. So at this level, very high abstract level.
Discourse is over 20 sentences.
Discourse is this tree is for a paragraph. Think of it tree for a paragraph of text.
Boris, if you were to speculate in this topic, right? How deep do you think the roots of this go? So for example, I think GPT by OpenAI models.
Yes.
They are more democratic kind of way, right?
Mm-hmm.
Llama models from Facebook, I think they're more like kind of Republican. So So how deep that goes, right? Different perception of the world. Maybe not.
So the question is what's the level of liberal versus conservative in, I think it's a different dimension. What I'm describing is a different dimension. You can be sarcastic about, so Republicans are sarcastic about Democrats, and Democrats are sarcastic about Republicans.
Is it possible to prime a model? Maybe, we just need a different model.
Okay, so first of all, the thing is very complicated. So what I'm describing, that's rule-based, very explicit. This is not a learned model. I mean, how you build, deep learning builds this representation, but when you operate with them, it's all totally deterministic. So I'm making it simpler. It's already complicated enough so that you have to deal with this deterministically. So this is exact representation, two different meanings and exact representation.
Try to cover a few more slides.
Okay. Okay, so I have a couple more examples. So this is a, let's.
And when you go home, you should be able to recreate this diagram.
So let's look at this example. I just had the baby and it looks more like the husband I had my baby with. However, it doesn't look like me at all. And I'm scared that he was cheating on me with another lady and I had her kid. This child is the best thing that has ever happened to me. And I cannot imagine giving my baby to the real mom. And what I'm giving this, like I'm kind of making fun. This is official bureaucratic answer, like you go to whatever, and that's like official, politically correct answer. Medical therapist advice on dealing with child being born from an affair as follows. One option is for the husband to avoid contact, but just have the basic legal and financial commitment and so forth. So we have like the story and we have official answer. Now what I'm suggesting, look at this representation and laugh now. So what I wanted to show that to deal with that, you have syntactic level. So this is old-fashioned Stanford NLP syntactic parsing. You have part of speech and you have relationship between words in black. Then in red, you have discourse relation, like elaboration, like giving more, given more additional details. But here's contrast. You have to have contrast. Because in this story, there is obviously a conflict. This is like a disconnect with this story. So what I'm trying to make fun of, that official like family counseling gives you like politically correct, and I would say, and ChatGPT would try to give you as less informative answers as possible, like most broad, without really solving the problem, without like trying to like wrap the problem with nothing. So this is what I try to show in linguistic structure. So if your question has a contrast, relationship of contrast, it has to be reflected in us. That's the purpose of this representation.
That example was like crazy because it didn't use a piece of common sense that wasn't stated. You know, that.
But that's exactly what.
Women have their own babies, right?
That is what,
So
that exactly.
you can't like figure that out from the syntax of the sentence, right? You need to bring in this extra general common sense knowledge that if the woman
Yeah,
has
that's
a
right.
baby, it's hers, right? Specific. Yeah, right. So I guess I don't understand how the syntax helps the fundamental issue with that sentence.
Okay, so in this case, you have syntax, you have semantic, you don't really have ontology. Like the difference between man and woman. So you rely on a logical, like language analysis, but not on ontology. And I'm sure like language model knows that. And in this example, I wanted to show how like question and answer is mapped in syntactic and semantic and the discourse space. Okay, maybe I think it's a one enough example to conclude.
Okay, did you have it? Did you wrap up your discourse section that you started?
Yeah, so what is missing is overall machine learning architecture, but I think let's do it other time. So so basically, if you look at high level, so there is a language model, and then you do something on top of it. How can you generalize? Like a few months ago, I was presenting fact checking, how to fighting hallucination. You have a language model and then something above it which repairs it. Here, personalization is also kind of repair. So you have different approaches to repair language model. How can you take it to the next level of abstraction? So what is a learning framework which is like repairing disadvantages and problems of language model? And that is what I call shaped charge learning, but I think
I mean, just a question to the audience. Would you like to say another 10, 15 minutes to do another section, or is there show of hands? Okay.
Okay.
You kind of leaving us with that story. We really want to see how it ends. Because you're seeking to give a better answer after it does all this fades away.
That is not the purpose. I just wanted to show what I wanted to show. Okay, what I wanted to show, like a real like life situation, and then a bureaucratic answer, which is sometimes you meet in life, sometimes, and language models are very common in providing answer like this. I'm kind of trying to make fun.
So you're showing a problem. I think what he was asking is, do you have a solution?
So solution is coordinated, coming back to my examples, solution, this answer should be rejected. The person going to like family therapist should say, I'm not accepting this answer because discourse tree doesn't match. Give me different explanation, give me different advice. So this advice breaks our strategy for communication personalization.
So a solution would be the discourse tree, but detect.
Just parse, do discourse tree, parse it and see it's not compatible. Give me different. That's wrong answer. Give me different. Not factually wrong, but wrong by style. Yes.
Like just like a different model. I think inflection AI feels like more like conversational model. Versus like OpenAI more like yeah. So maybe that's one way to solve it. We should train it to be more conversational.
Because I think some language model can it learns from text, so a language model can invent discourse representation automatically and then apply it. It's possible if you have proper training. Curious to see. It is possible. So this whole thing which I'm doing like explicitly, automatically picked up by language model. Just trained differently.
On this example is, if you switch to genders,
Mhm.
right, then the beginning part could make perfect sense, right? I'm a man, my kid doesn't look like me, I'm afraid my wife had an affair, blah, 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 and it gives some advice that, logically makes sense, here's how you deal with an affair, blah, blah, blah. Now you reverse the genders, and the syntactic relationships
Stays.
are the same,
Yeah, yeah.
but it's now it's nonsense, because it's missing this basic semantic connection. So I don't understand how a syntactic analysis can resolve this problem.
Oh, it's not. That's why in discourse level, it is not.
Okay.
Your question?
Okay, resolve it.
Okay. Again, we can back to DNA test again. Okay.
I think you brought up a very interesting idea. Language model can deal with this bureaucracy, like bureaucratic,
Yeah.
information. I feel like maybe in the future, if our language model can be smart enough, and it can detect the ironic from this statement. Like when you show this case to everyone, basically everybody just laugh out because we know this makes no sense, right?
Yeah.
So if I feel like maybe in the future at a point, language model can understand, oh, this is irony, right? This is,
By the way, yeah, and
yeah,
exactly,
this is,
totally not
sarcastic,
working.
right? And that this make no common sense, but it's a very nice standout comment.
I should say that is my other project. So right now, ChatGPT gives you answers, and then if you correct it, it can confess, yeah, I was wrong, and but that's it. There's no more. So what I'm saying is there's a whole diversity of communication modes which should be, and out of this whole diversity, I mean, we have language model, but it only acts in terms of dialogue management. It's very, very limited.
Well, I feel like in ideal world, the ChatGPT can tell you the ideal answer is ha ha ha, very funny. This is a false statement. You are missing the basic information, right? A female, pregnant woman cannot really have other one's kids, something like that, right?
Oh, I'll try. I didn't try.
Point that out, or maybe people like joke back, right? They'll crack some other jokes and follow up with a flow. So I think that probably a better a solution for all these method models. I don't know.
By the way, this is a real from Yahoo Answers. It's a real question. It's not invented. It's a real question. Somebody asked.
Real from where?
From Yahoo Answers. It's not. It's real.
Just put in that question to Inflection AI.
Yeah.
Give a good response.
What did it say?
Oh, wow, that sounds like a really complicated and emotionally challenging situation. It's understandable that you would be worried about the possibility that your partner may have cheated on you. However, it's important that remember it's not uncommon for children to look like, so it doesn't really, like, this is not factual. Yeah.
Yes.
Yeah, so I see like there is a question, and there is an answer, and there were other suggestions where, it can put another joke or sarcastic comment, something like that. But why wouldn't it ask the question saying like, are you sure, did you read whatever you said? And this looks like, it can even say like, what is wrong about the statement that.
Like question validation.
Yes. Why can't it ask question? How do we make it ask again?
Yeah, very good question. That is not related to personalization, but that's a very important. Just personalization is just one dimension of improvement, and question validation. It's another. So one way to do fact checking, for example, you can try to convert this question in a form for fact checking, because you formulate your question based on some facts, and if your facts are wrong, yeah, I will look at this. I didn't have this idea. I will look at this in terms of like, think of this as a LLM hallucination, because theoretically LLM could possibly hallucinate like this, and then would I be able to identify it?
Did you have other content you mentioned about the model architecture?
Yeah. So we proceed. Yeah. Okay. Then let's switch gears. So in general, in a lot of work we do, so some stuff LLM do great, we appreciate it, but sometimes we have to fix. And in this work, a lot of motivation. We integrate deep learning, explainable near stable learning. what is good about it? Deep learning can operate huge data, can quickly navigate through search space. But then if you do the last bit with nearest neighbor learning, you know which neighbors are close. And once you know which neighbors deliver this prediction, explanation is obvious. So we combine deep learning and the nearest neighbor learning. So again, there's a huge search space, like for example, content generation. We generate content with deep learning. We have a prediction of the probability of next token, but then we want, for whatever we generate, we want to find nearest neighbor, which is a kind of verification. If you don't find nearest neighbor, it means we cannot trust this content.
Is it nearest neighbor in an embedding space, or what are the dimensions?
Okay,
And repeat
nearest
the question.
neighbor is in embeddings. Yeah, for example, we generated phrase, and then nearest neighbor is the distance between this phrase and something on the web.
In embedding space.
In either embedding space or just whatever, can be different method. Can be embedding space, can be like common graph, for example.
Like, well, that's what I thought, but he was saying.
May not be. So like, for example, for fact checking, I'm not using embedding. I'm using like specific like grammar rules. I'm using phrase structure. So I'm using embedding of individual words, but I don't use embedding of phrases because I think it's not accurate enough. But that's a separate discussion. In general, as the idea, we have huge space, and it explained, it is the analogy here. We have a projectile. First, it flies a long distance, and this is deep learning. But then when it finally hits and punctures, it's a nearest neighbor. It's a small, compact, limited number of neighbors, but that part is explainable. That is why.
Between explosive and algorithms.
Okay, so DNN is like when the projectile is flying, but the heating is because heating is localized. And puncturing and heating is has a limited amount of neighbors, and then it has limited amount, so it becomes explainable. It's like obvious and clear.
So you could just say nearest neighbors more for global understanding, and the nearest neighbors for very local small subset.
So nearest neighbor for small subset, and deep learning for navigating huge possible space of predictions. And that was for question answer. So how do question answering? You first you do question answering using large language model, but then you verify by semantic and syntactic matching of question and answer. They should match. What we discussed, what we looked at discourse matching, but you can verify with syntactic and semantic. So think you have deep learning for finding candidate answer. But then to confirm it, to approve, you build syntactic representation similar to our, similar to this example. This is question, this is answer. We actually build a syntactic structure for each. We do semantic mapping, and we confirm that all issues, all entities in the question are explained and addressed.
So I'm trying to, I don't know if I fully understand it, but
Mhm.
I'm getting this picture like, I have a opaque neural network that is making a prediction. And so what I'm going to do is after it makes a prediction, I'm going to use retrieval augmented generation, which is finding the nearest neighbor.
Yeah.
To retrieve a bunch of facts, and then I'm going to give those facts and the conclusion from the deep neural network to the language model. I'm going to say, explain the finding from the deep network. Here are some facts you can use in your explanation.
That's kind of good description of what is. Repeat it for YouTube to record it. Okay. So the question was that RAG, retrieval augmented generation, is similar, follows this approach. So first you use deep learning again to navigate a bigger space and find candidate predictions. But then for candidate predictions, you try to find nearest neighbor, either apply rules or find nearest neighbors, do something explainable and local, to select out of few, not select from million, but select from few. And this way, you get the best of both worlds. It's like you don't need to do feature engineering, and for huge space, it's taken care by without feature engineering. But then in your localized space, you find nearest neighbor, then you explain why. You have your prediction and explain why. So you link your prediction with existing example.
Could you re-explain the relationship between feature engineering and
Okay. So for deep learning, the beauty of deep learning, you don't do feature engineering, it's all automated. But without feature engineering, you don't have explanation.
Why, I thought you, in your general pre-processing, you still need to do feature engineering even if you're using a deep learning model. So why would you need to not do feature engineering with the deep learning model?
Okay, so you collect for deep learning, you collect a lot of text, you do masking. So where is feature engineering? You do collect a lot of text, you just clean them.
Let's just say you want to take a ratio of 2 columns. Why would you avoid doing that with a deep learning model?
If it's a language model, it's not he's not doing numerical
Okay.
prediction. He's doing
Oh,
language
okay.
models.
Right.
He's not predicting.
Like you build language models, you don't do feature engineering. You just take a lot of data.
Okay, so you wouldn't be processing the textual data at all. You would just be taking.
Yeah, unless you count the tokenization would be the closest.
Okay.
Because feature engineering.
Right.
Well,
It would
it
just be
may
tokenization.
or may not be doing feature engineering itself.
Yeah.
Presumably it is. I would suspect it is.
But if you have huge billions of text, you don't have specific, you don't, when you train your language model, you're doing your masking, you don't say these are important words, pay attention to those words.
Yeah.
You don't
I
do
see
that.
what you're saying.
That
It's
would be
hands off,
feature
you
engineering.
don't- Yeah.
But with nearest neighbor,
Right, okay.
but with nearest neighbor, example of nearest neighbor, fact checking, you say, this is a incorrect fact, this is wrong fact, because I didn't find close fact. This is a correct fact because I found confirmation on the web. So this is illustration, this is nearest neighbor. I found confirmation for this fact on the web. So then therefore this fact is true.
Okay.
But at least in the old, Google, we still have the, limitization, one shot, 2 shot, 3 shot.
Oh, okay. When I call feature engineering, it's not cleaning tokens. I mean manual design of features. Feature engineering, it's a manual. We don't do manual design of features. Okay, we can do feature transformation or whatever. Just we don't do manual, old-fashioned, expert system designer. Okay, this is my problem. This is my domain. I need to have a domain knowledge. I need to formalize it. These are the rules. You don't do it now with language models, luckily.
Yeah.
Okay. I will skip limitations. And so there's a problem with representation of environment. Insufficient, usually in deep learning, this insufficient capability to form representation of the real world, high level of generality, allow easy and efficient manipulation of representation. You cannot represent, you cannot manipulate. LLM is a whole, you cannot manipulate it. You cannot take it into two pieces. And once we apply if you apply classical logical approach to machine learning, inductive logic programming, then user request explicit generalization results. So generalization is obvious. For example, you can define, we know that neural network does generalization. We know that language models do generalization successfully, but we don't know exactly they do it. We don't know, we don't see. But if you operate at logic level and in the nearest neighbor, we can generalize question and answer. Generalize means find common part. What is the verb? What is the predicate? What is the subject? So we can explain this is common between question and answer. This is not common. So this is a generalization. And if you can do it on top of deep learning, it is beneficial. Is today, we saw it's beneficial for personalization. It's also beneficial, for example, for fact checking and content generation. With doing last step, doing nearest neighbor, we improve the factuality of content generation. And also in search and summarization, similar advantages. All similar abstract concept formulation. Once we have, for example, integrate DNN, this such branch of machine learning called the formal concept analysis. It only operates with concepts. It forms lattices of entities. And then you can explicitly say, like, this is, here is abstraction. This is what, like we got close, like using deep learning, we got prediction candidate, we are close now, and we can build a lattice and say, this is a very, very close, but this part is different, that part is different. Then causal link. Probabilistic nature, how we build masking doesn't, I mean, there's some work, but essentially doesn't explain what is cause, what is reason, what is cause. And using like classical logic, we can. So if we can find approximate answer with deep learning, but then exact answer with logic, that is beneficial. And we show like this with abduction. Example of abduction. Let's look at, let's skip the math. Let's look at, it's called path kernel learning. We have like gradient descent. We navigate through like different variables. We want to figure out which variable is more important. So it turns out that nearest neighbor can also, so we have gradient descent in neural network learning, but we also have gradient descent in nearest neighbor. So I combine these two, and this part is trajectory in DNN, I mean, in neural network, and last part is really descent in nearest neighbor. And what I'm showing here that this is continuous. So you can start, you can mathematically start in neural network, continue with nearest neighbor, and it's still like a transition from one space to another, but it's still the same trajectory. Let's look at example.
So when you do learning in nearest neighbors, then you're looking at what neighbors are closest to the point.
Yeah.
There's no weights on
Oh, there is distance in the metric space. I mean, nearest neighbor, you have distance, you have metric space.
Right.
So nearest neighbor, you can also express as gradient descent, just different descent. You have one type of descent for neural network and another type of descent.
Once you have the training data
Okay.
in nearest neighbors, that's fixed. The dimensions
Okay.
don't change.
Okay.
And the location of the points of the nearest neighbors don't change.
Okay.
So in gradient descent, you've got weight updates. You don't have any weight updates in nearest neighbors.
You don't have actually you have, okay. So there is you can represent, we can go into the math. I can give a link to the paper. So brief answer, you can represent. So first of all, the special represent general deep learning with gradient descent. There's some math involved. And for nearest neighbor, it's also. So what I'm doing, I took one like piece of math for neural network, one for nearest neighbor, combined it, and then try to show that there is basically just one long gradient descent. And each part I can give reference for. It's in the paper. I have links. I just don't want to. So for example, we have a question, then we navigate, and this, I think of it is a so gradient descent for finding answer, no inference time, not training time. Now you have different question, not very related, and then you step by step you navigate through close answer, and then finally with nearest neighbor you get exact answer. Trying to illustrate this idea in linguistics, which is not really intuitive, but
I think we use the gradients to declining gradients to find this trajectory, right? But that's not the one you're trying to calculate the semantic distance from different numbers. So you still have this, vector-based, tokenized-based, semantic distance to find which is close. So it's
moving in embedding space,
right.
weight vector. No, okay.
Right. So I think this
to
corresponds to his
generating different text.
Yeah, that's right. His previous proposal basically had this DNN, and that's your projectile. Like find this long distance.
So weight activation space, you're doing a walk, and then as you generate different spaces in the nearest neighbor, you're also doing a walk.
That's right.
In embedding.
So you don't necessarily need to walk. You basically just project to your into the space, right?
Interpreting from this curve.
Right. Right, yeah, I think, right, I think so. Yeah.
Oh, I have one question. From box kind of see that. So that's the final way the BNN uses.
So this is the final way, David. Final, like we have dimension, think of it like words, like different words with weights, and then finally, W4 it waits for the nearest neighbor.
So that's a
Which is also
transition from the neural net to.
transition to, yeah. I mean, it's actually, this is a different space.
So DNN gives the output and KNN takes the output and finds the nearest neighbor on top of it.
Yes, and again, what I explained for search, so you do search, DNN and neural network gives you approximate answer,
Yeah.
and then with approximate answer, you actually go to Wikipedia and just compute similarity between approximate answer and each sentence on Wikipedia.
Yeah.
And then finally you get exact answer.
Got it.
But you cannot go to directly from a question to Wikipedia, right?
Okay.
Yeah, so that is why we actually need deep learning, because deep learning from this answer, from this question to approximate but detailed answer.
What if we are not satisfied with the W4, right? And then what do we do? Like we again,
Oh, maybe there's no answer. If you're not satisfied, so nearest neighbor can say, if there's no nearest neighbor, if there's no nearest neighbor, then it's saying like no answer.
And it still use the previous answer to,
Yeah.
this is what I got closest, like we can have some sort of rule. To
yeah,
right?
that's something that.
So that we're taking like how make this architecture more specific, like adding features.
Yeah, maybe sometime you can trap in a local minimum or something, right? And then you can like give some bigger room, try to randomize, and hopefully drop to a lower level. So that's another idea problem.
Okay, so I think this is a good
Okay, yes, sounds good.
time to stop. Because we covered a lot today.
So, thank you very much. Thank you.
Could we have some questions in Galen for a minute?
Sure, of course, of course.
Yeah.
Of course.
Hi, my name is Shane.
So that we can all leave otherwise.
We just want to, I can move the chairs back and set the tables up. If you want to go walk up and speak, that's okay.
Oh, sure. I was about to contribute something very quick. I have three questions. One is about data availability. Second, architecture efficiency. And the third is performance, model performance.
Can you repeat this? GitHub link, I have, I can show it. Oh, I think appreciated that. Appreciate.
Oh, some temptation is not really rewarding, but anyhow, yeah, fantastic talk. I mean, it's the most hardcore ever. So I try to say things on your you look a bit tired. Give it empathy. So yeah, last price you have is okay. I'll go by order because I was like save up, and I think since you're expert, like it should be not a hard things for you.
I would like to listen. I'm sorry.
Yeah, sure. And so first is the data availability. Is it possible to using zero shot or few shot, because like feature engineer, not really for deep learning, but I think for how can we using the zero shot in order to like kind of synthetic data generate like that. And then you were mentioned earlier the logical abundance thing, which is the evaluation process. How about go parallelly? So have the evaluation process like very defined, but you use first generate those data. So you'll skip the problem of like, oh, where's getting those data, blah blah blah, so on. So these two would be I mean, is it a good combo?
So you are asking about the question about this abductive part, right?
Yeah, I mean, these two parts go together, so you don't need to worry about it's a data available. So just these two things I go well.
So the question, you have a language model
Mhm.
and it consumes, it processes a lot of data, but we don't know which common sense reasoning is there, which is not. So in serious tasks like finance and health, we adding logical part. And then that's the hardest part, because then we need to somehow combine, and that's the hardest part now, because what language model do well, they do. But sometimes what they don't do well, then we augment with a logical. And then how do you do, like,
I
how
see, I
we
see.
actually combine? Personalization is one example.
So you actually somewhat partially answered the first question I have.
For example, language model knows in general about expertise, but in this task, I really want, okay, expertise level is very important. So just throw away everything else if you cannot match expertise. Like I want, it's like software. I have base class large language model, and I have subclass with logic, and I want in my subclass override all decisions where expertise level is wrong. So think of it as like
Makes sense.
I'm overwriting. So I'm trusting a language model, but to a degree. If I have problem with matching expertise level, I want my rule. I don't care what language model says. I want my rule.
I see. So only at that point trigger like a certain condition, then do the real evaluation.
Yeah, and then you evaluate the whole thing.
Okay, and then the second is the last slide seems very applicable to the vector database. So, but I also seen that it's also perfect case for combination with the graph database. So they have a different usage and will be.
Yeah, you have graph database, and then you have. So okay, that's a good example. You can do embed graphs.
Yep.
So you can learn embedding graph, but then at the very end, you still want maybe to match graph, because when you match graph, you know what you match with what. And that's explainable, because once you embed graphs, it's all become there's no explanation. It all becomes like puzzle. When you match exact graphs, like for example,
so at that time you want to reduce the fuzzy search.
Yeah, because last step you have exact graphs, and with the exact graphs as a human engineer, you look and see, oh, these two edges are matched, but they shouldn't have.
I see.
Because when you do embedding, you don't know what is happening.
Then it's like a cross validation.
Yeah, then you know exactly what is matching. It's kind of additional due diligence. Okay, let deep learning do embedding, let it calculate, but then I need to really verify.
Got it.
Last step, you will fully verify, so you can trust it.
So it doesn't need to be fully verified to 100%. I mean, because it can be, but you just like
some kind of explicit verification.
Consume too much computational power in the case. I mean, maybe like
nearest neighbor, it's
such a
also expensive, but
such a bandwidth, maybe 80, 85, 90 something. That's seem good enough. I'm thinking.
Yeah, obviously, because a nearest neighbor also has limitation. You define distance in the nearest neighbor space, and this distance also has problems and has limitations, and does cover all cases. So it's not ideal, but at least it is explainable. You understand why? So you're saying the weather tomorrow is going to be rainy because similar previous day 5 years ago that exact date were rainy. I can give an exact example why you predicted.
Yeah, I even think about some other like most minimum way to verify. Like, but anyway, the first one that would be like that's perfect. So stack model, and then having a like DMM, KM, all these things, and when their performance like maybe good at one task, and others. So would be good to like using multi-model methods. I kind of do get a last little bit. I think you answer partially of the first one. So yeah, is there a specific point? Are you implementing of this methodology so far?
What I'm explaining this shape charge, it's the philosophy. You need to. So like deep learning, like I'm working for a particular company. Deep learning is done for you. Like you already have language model. You're not going to do yourself. You already have it. So all your jobs need to repair. Like what you do, you are a repair shop, and repairing is actually doing nearest neighbor. So this is what I'm saying.
Okay.
like us, probably, we're not going to build our own language models. They build for us. What we're going to do, we're going to repair. And how about, can we have a systematic view? What are we actually doing? We are doing nearest neighbor learning.
Yeah.
We're repairing, like adjusting results.
Interesting, you mentioned repairing process. I certainly very enjoy the example. I design deep learning framework from time to time and also involved with financial data. I know that those are bottleneck and it's very hard to tackle, like many areas. So without further ado, may I take a picture with you? You know, I get to a very quick certain case. Do you mind to take a picture? I mean, you want to take time, it's like.
I was also like.
Okay, cool. Oh, just go search my name or,
Find my email.
uh,
My
yeah, probably need your, yeah. Well, you really follow me up.
I actually dropped in, I didn't know like this was happening.
Ah, I see. Oh,